Hey, and welcome back to Unit 4 of our SOL review videos for this year. Unit 4 is Order of Operations, and a reminder, this is a non-calculated part of this SOL. This goes over SOL Standard 7.pfa.2, and we're going to go ahead and jump into essential question number 1. How can using concrete materials and pictorial representations help you understand an algebraic expression? So I've got an algebraic expression sitting here for you. Remember, expression does not have an equal sign, okay? So this is just something that we are going to combine and simplify and end up with a number. So we will end up with it equaling something, but there is no equal sign present yet. Okay, so we're going to go ahead and use and look at PEMDAS and GEMS. You can use either one, whichever one you prefer. I think I'm going to refer more to GEMS during my videos because I think it is more inclusive of reminding you that you have parentheses and brackets and the absolute value signs. Okay, so I've got an expression ready for you right here. We have 3 times 5 plus 4 minus 1 divided by 3. Okay, and using GEMS, I know the first thing I need to look at is what is in the parentheses and the bracket and the absolute value signs. Okay, so we have parentheses. So that just asks what is 4 minus 1, and that's going to equal 4 minus 1 equals 3. If I was drawing a pictorial version of that, I would have had 4 boxes. Super duper fancy. Let's put the fourth one up here. Okay, 4 boxes and minus 1. Well, minus means get rid of. So now we just have 3. Okay, so I have 3 here. And then the next thing I need to look for is exponents. I don't have any of those. And then multiplication and division. And so I already have 3 boxes here, and that's because I know I'm going to start with this 3 right here. And then where I have division over here as well, I know I have to do this piece, 3 divided by 3, and I have to do 3 times 5. I can do both of those separately, but I can't do anything combining them yet until each one is done because there's that addition sign, and that is part of my last step in the order of operations. So first I need to do what 3 times 5 is. Well, here's 3, and I need 5 of those. So that's going to give me, this is 2 3s. Let's go and put one here. 4. All right, there's 3 sets of 3. 4 sets of 3. And 5 sets of 3. And remember that when you're in your multiplication and division step, you just go from left to right. And then once we get to our addition subtraction step, we're just going to go from left to right. So that's why I did my 3 times 5 first. So I had 3 blocks, and I made 1, 2, 3, 4, 5 of them for a total of 15 blocks. Okay, and then I had this 3 that I created earlier in my parentheses, and so I put it off to the side because it was in parentheses, so I wasn't using it yet. But now I have 3 divided by 3. So what I'm going to do when I'm dividing, that just means I need to break this into 3 groups. Well, I can circle 1 here, circle 1 here, circle 1 here. So how many was in each group? That's 1. So 3 divided into 3 really creates 1 in each group. So 3 divided by 3 is 1. Okay, each group had 1, right? So then I had 15 plus whatever this gave me. So I'm going to go ahead and get my 3 divided by 3 out of the way because that gave me 1. So I had 3 times 5, which gave me 15, and then they want me to add that 1 to it. So if I add the 1 right there, get rid of it over here. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 3 times 5 plus 4 minus 1 in parentheses divided by 3 equals 16. All right, so that's how using the concrete materials, using pictorial representations, gave me a quick little representation and a visual of how that would work, right? There's other ways you could do it technically. You could use the number line, right? You could have start on the number line and jumped around for different things, right? And that might help you if you had a version with absolute values, okay? It might make that a little bit easier. But this is just a quick little um, representation of how you can use concrete materials and like blocks and such to represent an algebraic expression.